Hi guys, welcome to the Pandas for data visualization now. In the data analysis section, we have explored the power of Pandas for data analysis. Let's talk about Pandas' built-in data visualization capabilities now. We can create decent looking plots using Pandas. This is actually built on Matplotlib and embedded into Pandas for quick use. Let's move on to the Jupyter Notebook and see how we can use Pandas' built-in data visualization capabilities. So the first thing first, let's do some imports. Import numpy as np and import pandas as pd. And let's set matplotlib inline. So let's run this cell. Let's create some random data sets. We are going to create two data frames, df1 and df2, one with date as index and the other with sequential index. Although we can use C-bonds built-in datasets as well, but I want to make this lecture separate and independent. This is why I am creating new data frames here. We can use date_range from pandas to generate dates. So dates equal to pd dot date_range, and we pass in some random start date 1/1/2000 and periods. So how many days we want? We want 500 days. So if you press Shift Tab, you will see range of parameters that we can pass in: start and period, frequency, and a couple of other parameters. So here we are giving a start date and how many days after this date we want. Let's run this cell. Let's generate another series using numpy's rand function. So let's call it call_d at the moment, and np dot random dot rand, and pass in 500 because we are generating 500 dates and we are generating another column with 500 random numbers. Let's move on and use numpy's rand_n function to create a 2D array now. So let's call it data1 equal to np dot random dot rand_n, and once again let's pass in 503. So we want 500 rows and 3 columns. So let's run this cell here. Now we have dates, column D, data 1. Let's create a data frame now. df1 equal to pd dot data frame, and pass in data equal to data 1, and pass in index equal to dates, and columns equal to A, B, and C. So let's run this cell and check the head of our data frame. So here we have our data frame with 3 columns A, B, and C, and our index are dates. Let's add call D to our data frame now. I hope you know how to add a new column to the existing data frame. So df1, pass in the new column as D equal to call D. Run this cell and check the head of the data frame df1.head. And now we have index as dates, A, B, C, and D columns. Let's create another data frame now, and we can use numpy's rand function again. So data 2 equal to np dot random dot rand, and say we want 20 rows and 3 columns, and our columns are x, y, and z. And df2 equal to pd dot data frame, pass in data equal to data2 call. If you press shift tab, you have data index columns. So we have columns as call. Let's copy this one from here. I hope you remember all these things from the Pandas data analysis section. So equal to call. And let's check the head of data frame at the same time. So what we are doing, we are generating random numbers here, 20 by 3 matrix, and then creating a list of columns and passing that data to the data frame, and columns call to the data frame, and creating a new data frame df2, and then checking the head of the data frame. Let's run this cell. So here we have our second data frame df2 with index as 0, 1, 2, 3 and xyz as columns. We are actually going to learn the data visualization capabilities of Pandas. Let's start with a simple histogram plot. We can get histogram plot in two ways. We can call DataFrame.hist, or we can call DataFrame.plot and pass in an argument kind and tell the function plot what do you want in the output. Let's try both of these one by one. So df1, grab the column A and call hist, and let's run this cell. Here we have our histogram plot. If you press shift tab, you have a number of arguments that you can pass in, and you can change the bin size as well. So default is 10. Let's change this bin size to 50, and here we have the same histogram with more number of bins. So we can also use df1, grab the column A and call plot instead of hist, and then pass in kind equal to hist. So here we have the similar one. You can press shift tab again and see you have range of parameters you can play with. So let's pass in bins here again just to get the same plot. So bins equal to, we passed in 50 here, and let's pass in 50 again. If we run this cell, here we have the same plot in two different ways. The only difference is in this case we are getting this grid, and in this case we are getting a white background. So let's move on and start with style sheets. Matplotlib has style sheets. We can use this to make our plots look a little nicer. If you go to the Matplotlib's style sheet gallery, you will see they include plot BMH, plot dark background, and plot 538, and range of other options. Let's try to use a couple of options here. For this, we need to import Matplotlib as well. So import matplotlib.py plot as plt. Let's start with the very commonly used style sheet. So plt.style.use ggplot. Let's run this cell here and replot this histogram. Copy this one, paste it here. So here we have our same histogram but with different style sheet. Let's try another style sheet. Copy this one, paste it here, and instead of ggplot, let's set BMH and copy this code and run this plot again. So what we are doing, we are setting the style sheet and at the same time running this code to get the histogram. So here we have another style sheet. We can try another one. Say we can try dark background. And if we run this cell, so we have another style sheet. It's all your preference what type of style sheet you want to use for your report writing or to present your data to the audience. You can set another one, which is again commonly used, 538. So if you run this cell, here we have another style sheet which is 538. Let's set the style sheet to the most commonly used one, which is ggplot. And we are going to use this ggplot in the rest of the section. So moving forward, let's talk about the type of plots. There are several plot types built into Pandas. Most of them are statistical plots by nature. Like we can get area plot, we can get bar plot, histogram, line plot, scatter plot, box plot, hex plot, KDE, and so many other options. Let's go through these plots one by one using our data frames df1 and df2 and start with the area plot. Let's grab our data frame df2 dot plot, pass in kind equal to area, and run this cell. So here we have the area plot for our data frame df2. We can pass in alpha argument just to control the transparency and run this cell. So here we have changed the transparency in our area plot. So instead of passing kind as area, we can use df2.plot.area. Run this cell, and here we have the same plot. We can pass in alpha equal to 0.5, and we are getting the same plot with df2.plot.area. So either we can pass in kind equal to area or we can call plot.area. So let's change the size of this screen. Here now we can see these two plots in the same window. So moving forward, let's talk about bar plots now. Grab the df2 again and call plot.bar. Let's run this cell, and here we have the bar plot for our whole data set. We can get the horizontal bars using BARH. So this is going to change bars from vertical to horizontal. So let's run this cell. Here we have these bars along horizontal direction. We can stack these bars on top of each other as well. Let's add few cells and df2.plot.bar and pass in stacked equal to true and run this cell. Here we have these bars stacked on each other. So we have X, Y, and Z, and they are stacked as red, blue, and maybe light purple color. So let's move on to another plot, which is histogram. Before moving forward, let's make it a little bigger now. So let's grab data frame 1 now and column A and call plot.hist. We already did this plot in the beginning and run this cell. So this is our histogram. So we can pass in bins equal to say 30 to get the better histogram plot. Instead of one column, we can grab the whole data frame and plot histogram for all the columns. Let's run this cell here. So here we have all the columns on the single canvas. We can pass in alpha here equal to 0.5. So here we have a better looking histogram plot. Similar to bar plot, we can stack the histogram plots as well, and we simply need to pass in stacked equal to true. So let's stack all these plots together. df1 dot plot dot hist, pass in stacked equal to true, and run this cell. Here we have these plots stacked on each other. If you look at the frequency here, 0 to 100, and here we have 0 to 600. We can pass in other keywords which are supported by matplotlib hist as well. For example, horizontal or cumulative histograms can be drawn by orientation equal to horizontal and cumulative equal to true. Let's pass in orientation equal to horizontal and see how it works. So we can copy this code, paste it here, and pass in orientation equal to horizontal, and let's pass in alpha equal to 0.5. So let's run this cell, and we have changed the orientation of our plot from vertical to horizontal. So moving forward to line plot, let's grab DataFrame df1 and plot.line. We can grab x as index df1.index, and our y is, say we want b, and let's run this cell. Here we have a line plot. It doesn't look very nice. Let's pass in another argument, line width equal to 1. Looks like it's very thick line. So here we have better looking plot. We can change the figure size as well. So we can pass in fig size equal to, say, 12 and 3, and run this cell again. So here we have a better looking plot for our data. One thing you notice here, if the index consists of dates, it tries to format the x-axis nicely as shown in this plot. Actually, it calls matplotlib's built-in function for this purpose. So moving forward, let's talk about the scatter plots. Scatter plots can be drawn using the DataFrame.plot.scatter method, or you can simply pass in kind equal to scatter. Scatter plots requires numerical columns for x and y axis. These can be specified by x and y keywords. Let's grab df1 and plot a scatter plot for x equal to a and y equal to b. So df1 dot plot dot scatter. You can press tab for autocomplete. Pass in x as a and y equal to b, and let's run this cell. So here we have a scatter plot, x as a and y as b. To plot multiple column groups in a single axis, we need to repeat plot method specifying target axis. It is recommended to use different colors for both columns. Let's try to put another column on this plot. So ax equal to df1 dot plot dot scatter, pass in x equal to a, y equal to b, and let's say we want color equal to dark blue. So run this cell here. So here we have our a and b in dark blue color. We can copy this one, paste it here, and instead of x equal to a, let's see, we want x equal to c and y equal to d. We have other two columns, and instead of dark blue, we can say we want dark green. And where this plot should be ax equal to ax. So we want this plot on the same canvas. So let's run this cell. So now we have multiple column groups in a single axis here. We can pass in label here as well. Say group 1 and copy this one, paste it here, and pass in group 2. And here we have group 1 and group 2 label. This is not really a very nice color actually. In the scatter plot, keyword C may be given as the name of the column to provide colors for each point. And C map can be used to indicate the color map. And we have range of options in the color maps in Matplotlib. If you want, you can explore all these color map options on the Matplotlib's documentation. Quite healthy options we can select from. So let's pass in C here as well. df1 dot plot dot scatter, and x is again a, y is again b, and let's pass in C equal to column C. So we want to color our plot based on column C and run this cell. So here we have the default color. We can pass in C map and say we want cool, warm. So it's much better plot in different colors based on column C. So we can change the size of these data points, and for this we can pass in S, say we want 50, and rerun this cell. So here we have the bigger sizes. Let's pass in 100. So here we have much bigger sizes. It does look that good. So let's pass in 50 again and run this cell again. We can use this S parameter to indicate size of the bubble based on another column as well. So S parameter need to be an array, not just the name of the column. So let's copy this one, paste it here. Let's add few cells again and delete this C. Instead of S equal to 50, grab the column C here and delete this one as well, because we want the bubble size now. So let's run this cell. So here we have these dots. One thing you notice, this error. So this is runtime warning. We have some negative values in column C. This is why it's giving a warning and telling us the square root of negative value is not possible. So these are very small. Let's scale them and multiply by 100 and rerun this cell. So these bubbles look much better now. So the size of bubble is based on column C. Moving forward to the box plot, which is used to visualize the distribution of values within each column. Let's grab our second data frame now, df2, and call the box plot dot box and run this simple one-line code. And here we have our box plot for X, Y, and Z columns. We can change its orientation. For that, we need to pass in vert equal to false. Here we have changed the orientation of our box plot. Box plot can be colorized by passing color keyword. We can pass a dictionary whose keys are boxes, whiskers, medians, and caps. If some keywords are missing in this dictionary, default colors are used for the corresponding artist. So let's create a dictionary, color, color, and dict boxes. We want dark green color, and whiskers we want, say, dark orange color, and medians we want dark blue color, and for caps we want, say, gray color. So let's run this cell and call df2 dot plot dot box and pass in this dictionary color equal to color, And if we run this cell, we have the box plot according to the given colors. We have dark green, orange, gray, and dark blue. We can also pass in by argument for group by in the box plot. Let's create another column to our data frame with two choices A and B. We can add df2 group, a new column, and call np.random.choice and pass in the list of our choices A and B. So we want this new column group, and the choices are either it should be A or either it should be B. And what is the size of our column? How many rows we want? If you remember, we had 20 rows in our data frame. So let's run this cell. So it should be size. Let's run this cell and check the head of the data frame. So here we have new column AB, AB, B. Let's add few cells and plot the box plot again. So we can use df.boxplot to plot box plot as well. Let's grab two columns from our data frame and use df2.boxplot here and pass in columns, which is list X and Y, and pass in by. We want to group by the group column. So we are grabbing X and Y columns from our data frame and passing by equal to group. This should be column. So let's run this cell. So here we have our output. I'm going to drop this column group because I don't need this column anymore. So we can drop this using df2 drop and pass in the name of the column and pass in axis because by default it is 0. So we want to drop column, so pass in axis equal to 1 and in place equal to true. Let's check the data frames head as well. df2.head to see if the column is dropped. Let's run this cell. So here we have the data frame in its original form. Moving forward, let's talk about the hexagonal bin plots. Hex bin plots can be useful and they are alternative to the scatter plots if your data are too dense to plot each point individually. Let's call the hex plot on our data frame df1. So df1.plot.hex bin, pass in x equal to A, y equal to B, and let's run this cell. So here we have our hex plot. A very useful keyword argument is grid size. It controls the number of hexagons in the x direction. A larger grid size means more smaller bins. Let's pass the grid size equal to 25 and see how the above plot looks like. So grid size equal to 25 and rerun this cell. Here we have much better looking hexagonal plot. We can pass in cmap as well. cmap equal to oranges and run this cell. And here we have a different color map now. So moving forward to the kernel density estimation plot, KDE plot. Pandas provides an option to get the KDE plot as well. So we can simply call the KDE plot on a single column. Say we want X from data frame df2 and plot.kde and run this cell. Here we have the kernel density estimation plot for our X column in data frame df2. Instead of KDE, we can use density as well. and it's going to give the same output. So KDE plot we can get either from density or KDE. If we want the KDE plot for all the columns in our data frame, let's delete this X and run this cell again. Here we have the kernel density estimation for X, Y, and Z, all the columns in data frame DF2. The last one I want to talk about is a pie plot. Pie plots or pie charts are very useful in most of the cases. And Pandas provide a built-in option to get the pie chart using .py function. Or you can pass in kind equal to pi as well. One important thing to remember, if our data includes NaN, during the pie plot, it will be automatically filled with 0. And a value error will be raised if there are any negative values in our data. Let's try pie plot with data frame DF2. df2.plot.py, and we need to specify our column. So y equal to x, we want to grab the x column, and let's run this cell. So here we have our pie plot. The plot doesn't look very nice. Let's remove this legend and set the figure size as well. We can pass in fig size. Let's pass in 4x4 and pass in legend false and rerun this cell. So here we have better looking pie chart for our X column in data frame DF2. Instead of passing y equal to x, what if we want pie plot for all the columns in our data frame DF2? In that case, we need to set another argument subplot equal to true, and it will generate pie plot for all the columns in DF2. df2.plot.py, pass in subplots equal to true, and run this cell. So here we have our pie plots. Once again, they don't look nice. Let's pass in fig size equal to 12 and 4, and we don't want legend as well, so legend equal to false. Let's rerun this cell, and here we have the nice looking pie charts for our data frame DF2. X column, Y column, and Z column. So this was all about the data visualization using Pandas. You can see that how convenient it is to use Pandas for data visualization while doing exploratory data analysis. It balances ease of use with control over the figure. A lot of plot calls also accept additional arguments of their parent matplotlib library. So let's move on to the exercise section now, where we will try to solve some tasks related to Pandas data visualization. See you in the next lecture. Good luck.